Um, about that. Okay. Welcome back, guys. Let's continue and let's do it this time around so that we can be done with this stuff. So, still waiting for people to join the class. So, as we were saying, um, making use of the ordinary encoder now. So, making use of the ordinary encoder to encode this particular value, just create the ordinary encoder, make use of the class name ordinary encoder. You set the categories and in the order you want it to be encoded, and you set this particular value to it. If you want to know more about ordinary encoder, just this same stuff, ticket length of pre-processing, label encoding, not label encoding now. That's ordinary encoders. Ordinary encoders. It will give you a full and total documentation of the various values that you could use, make use of. That's if you don't want to make use of the documentation directly from your camera. I'm most likely prefer just reading everything at once, but I like to just leave my environment if it's necessary. That's it for the label encoding. You can see that it's a very simple mode of encoding. And unlike sorry, that's for the ordinary encoding. And unlike it, for the label encoding, it's pretty straightforward. You just don't need this particular aspects for an ordinary encoding. With the ordinary encoding, just rename that the ordinary encoding, leave the parentheses and then you fit transform.
I have a question, please.
Okay,
I have a question.
Yeah, I'm listening.
My question is, if you how can you now apply this ordinary encoding in all the data sets that are categorical in nature? For example, now if you want to apply it on them, all the data sets that are categorical.
For the purpose of tutorial, that's why I actually try to separate them, like make use of label encoding and that. Personally, I hardly make use of label encoding since ordinary encoding can also do the work of label encoding. I don't know if you get my point. I most likely just prefer making use of ordinary encoding rather than making use of it. And I rarely make use of one-word encoding, not because it's not useful, it's extremely useful, but it depends on cases. And these cases are where the values of, say, the categories now are special. And that is when you see the data set, you will know it. So when, let's say, we want to differentiate between gender, male, female, and say transgender, these three genders now, it would be necessary now not to order the gender because you can't place hierarchy over male and female and all of this kind of stuff. So you might want to make it of a one order encoding to say, okay, this particular person is a male. So a male will be represented by one, while the others are like 0. That's when you make use of one encoding. But most of the time, I prefer making use of ordinary encoding. It's just straightforward and easy to use. But other than making use of ordinary encoding, I prefer doing something simpler like what I did in the why did I even do it? I think around here. I'm making use of the replace statement to change the values. Apply label encoding here. But this might be a more advanced form of doing it. It might be hard to see. But I'll still break it down, sure. Okay, that is here. Making use of making use of ordinary encoding to I explicitly state the values. And this was efficient because the data sets, the reason why I prefer this method is that it works no matter the size of the data set. So this data set that we are seeing here is reasonably small. And the reason why I say so is, okay, I'm even in one of my listings. I was actually working with a particular data set, and this is just like for a quick example. It's a small data set in the sense that it doesn't have much future colon. But when you scroll down, say something like this now, there are about 849,000 and 48,835 rows. Now, if you were to apply ordinary encoding to that kind of data set, you will actually take a while to process it. It will take a little while to process it because the ordinary encoding does not a form of direct mapping now, but it's kind of iterates through the list, studies the pattern and all of this, and then assign values to them. But making use of the replace statement does this automatically. So no matter how large the data set might be, making use of say say this now, this is a direction future column. That's for the data set I was actually particularly on. It has this EB standing for East Central, NB for North Central, Northeast, South Central, Southwest, West Central, and like that. Now, if you wanted to encode this now, if you made use of ordinary encoding, I'm not saying it won't be fast, but at least it will take a little while to process. Now, imagine if the data was still larger than this. That's why I still prefer making use of the replace statements to encode value directly. Not just because it's easier, but actually, I choose what the values will be, just as I did. And you can still do that with ordinary encoding by placing the error. And some people actually prefer ordinary encoding to doing the job. I just prefer Regression. So it's just a matter of preference. So let's quickly look at how label encoding works. So looking at how the label encoding works, say we have to look for an item that makes use of label encoding. That's this particular item. And I like naming my variables in brackets, so I will modify the variable name. So I'll just change it to item identifier underscore encoder. So I'll create the label encoder with this. Label encoder with this. And this is just all to it. So when I say the label encoder, I kind of replicate what I did around here. I really love the function of complexity and control. One of the most beautiful things in program. The name of the future column now is the item identifier. So I just want to change it to item identifier to non-file. Okay. I'll call this item identifier. That's the variable state showing the list, and let's review what it looks like. And value. This is the value now. This is the item identifier. You can see that it has been reshaped to such a way that has 2 dimensions. So it's a 2-dimensional array, and this is the values within it. So what I want to do now that I'm done reviewing it is I want to encode it, making use of this now. So we'll just go directly to the fit, calling the fit method. So say dot fit. If you say dot fit now, what value do you want to place in it? That would be the item identifier. So fit and what did you just say? Oh yeah, not item identifier, but item identifier encoder. The item identifier encoder, which is the encoder that we're looking at. It fits it and it's giving me a warning. Should be passed. It's not actually necessary. Get your point. So as I was saying, when after fixing the label encoder now, we've created a processor which can actually process the item identifier and convert it to a class. And what you can do is say something like that. You can say the item identifier encoder dot transform. So I just do the same thing here. Because what we often replicate is the fit and the transform. So the fit kind of like takes the value and fits it into the encoder, then we transform it into of this transform keyword. And there's another keyword called the fit transform. I will explain that in a bit. Maybe making use of the one out encoder. So I'll just convert this fit here to transform. So this is what it does. It transforms the entire item identifier code, which is this. Yeah. Transform it to numeric values, which the system can understand. So,
sorry, can you please explain the fit and the transform again?
okay, so for the fit, what the fit does is that, okay, imagine you are creating, let me make it an example now. Imagine you are creating a function. What and this function has the ability to learn. So what you are asking it to do is that, okay, the first time you are seeing this particular data, instead of actually processing it, don't process it, study it, look for the try to find the unique values among it, just as we did here at the very start of the notebook where we called for the unique values. List out those unique values. Then you could do such a thing as zipping numbers alongside it. So this particular value has 0, this particular one has 1, this one has 2, like that, 3, 4, 5, till it gets to the end. So it assigns a value. It assigns a value to each category. That is what the fitting does. The fitting tries to study the data and assign value to it. Now, after it fits it and assign a value to it, when we call for the transform now, the next time it sees that data set, which is the same thing that we made use of to fit the encoder, what we made use of to fit the encoder, the next time it sees the value, it's able to exchange or replace those values, kind of what we like did in this our column here. So with like saying, whenever you see this value, replace it with this. Whenever you see this value, replace it with this. But this time around, the values are going to be numeric. So I don't know if that explains the whole concept behind it.
Yeah, thank you.
Okay. So that's for the label encoder. I can see it's a pretty straightforward function. Very, very easy to use. So now coming to the one-hot encoding.
Sorry. So to use the label encoder, that means you have to transform each column to data frame from the series. You change it to data frame first.
I don't get your question.
You know, you said instead of it being a series, we have to change it to 2 columns instead of it being one column. So we have to change
the reason why, okay, let me put it this way. The reason why we were having that is because we were trying to transform a single future coding. And now, as I said, a series by nature is one-dimensional. That is the Panda series, is one-dimensional. So when we fit it into the encoder, it starts generating an error because the encoders by default are best suited for a two-dimensional array that is not having a single dimension. So we make use of this method here, the dot reshape, to like shift the array to become 2 dimensions. And okay, let me put it this way. There are 2 items that are best suited for label encoding, and I listed them right below. Yeah, okay. These are the items. That is this particular 2 items. The item identifier and the item type. So let's just quickly look at it. I'll close this. The item identifier is one of the this thing we are familiar with, and the reason why we chose it is it had over 1,500 unique columns, which is a lot, which is a whole lot. Then the item type is this. It has different future columns that doesn't necessarily have an order to it. So it doesn't need to have it doesn't need to make use of a ordinary encoding like this. A label encoder is just perfect for it. And if we were to check the I would say let's create the Google directory here and see label values and paste what we copied from there. So if we were to preview this now, I want to check for the unique values of the item type. So that will be saying the Big Mart sales dot this dot unique. So we realize that it has a lot of values within it, and taking the length of those values. So that's the length of the values alongside it. There are 16 values in it. That is for the item identifier. If we were to make use of a label encoder now, let's say label, I just call it label encoder. Normally, I like to definite it with my variable name, but to save time, I say this label encoder. So I'll make use of this label encoder to fit this two values now. What did I write here? Label. Label encoder. So I'll make use of these two values to fit our label encoder. The way I'll do this is that okay, the label encoder now, which is this label encoder. And maybe I should just make use of the fit transform direct. So what the fit transform does is it first fits the data, then it transforms it directly in place. And what I mean by it is that okay, after it performs the fitting, which is what we did here, after it performs this fitting, it performs the transformation as well, and it does it in place. So immediately the encoder is able to understand what categories belong to what value. It assigns the categories to the values immediately. The reason why they created this method is because of redundancy. A situation where they realize that a lot of people will often be doing this, that immediately after they fit with the whole data set, they will be transforming that immediately with the whole data set. So they just created a function that mixes, they created a method that mix both functionalities into one. So that's the fit. That's the fit transform. And what we do is that we ask for this, the Big Mart save. I like to actually visualize what I want to do in my Excel. So making use of this now, I just ask for this particular values, which I name the label values. So putting the label values directly here, we can see that we're able to generate both data sets. Making use of this. And if we ask for the type of this now, the type of this value, you realize that it's a data frame and not a series. Now let's fit this data frame. Let's fit this data frame into the encoder. So say the big Mart and oh no, not the encoder actually. Label value. It's giving us a value. Why should be it's got an array of two this. Okay. Let's say one thing is causing the it takes y. Okay. Sorry for the mix up. Label encoders can't process multiple shapes at once. Like, sorry, it can't process two samples at once. It can only process a one-dimensional distinct value, which is, I guess that's the reason why I made use of this particular form of encoding when I did it. So I applied the label encoder directly for each future column. This and this. But it should be a way. The time is going, I can't explain. But what will happen is maybe by our next class I will discuss a way we can resolve this. So we don't waste time discussing on this error. Let's just quickly move straight to the one-hot encoder. So the one-hot encoder is I like to name it OAD for one-hot encoder. So I'd like to say OAD and with making use of the item facts. So let's see the item facts. one hot encoder. Have one hot encoder. Let's see, is there any specific okay, there's the categories here. And what does the categories say about this? It's something similar as well to the ordinary encoding, but what the category does is that it kind of sets the order you want it to appear in. That is, okay, you say the male, female, that is making use of the gender example that I stated earlier, making use of the female, transgender. Now, if you place an order, say categories, what what it does is that it encodes giving the zeros and ones in this order. So it's like when it's encoding, all the males go directly. Males will be the first, females will be the second, trans will be the third. So basically, every time you see it, we take the first position, second position, and it also will encode it doing something like this. Say the female first. So the answer do this form of this, but since we won't be making use of this, we'll just make use of the auto. Since it doesn't really matter, this to me, it doesn't really matter. Just create the one hot encoder because of this variable and keyword one hot encoder. So I want to just copy this exact I have it of copying and pasting finally to so just say this. So let's say item identifier. I think I'll just say I'll rename it item underscore fact, but this time I'll add the content so it doesn't accept the last variable. So same thing with this. It fits and takes the value of the item part content. So actually can be used by like naming it, and then we take the transform. Maybe we start with the transform directly. Since we don't work with the label actually we put to the fixed transform. So what we just did, we run this we run the encoder to initialize it. Now the fit method that was used won't apply anymore because the variable name item facts weight for one hot encoding has been initialized to one hot encoder that hasn't been fitted on any data before. The data item path content remains the same. And when we say the fit transform, you realize that it creates what they call a sparse matrix. And basically, what a sparse matrix is it's nothing but values of zeros and ones. So we have say something like this. This is basically what we have, something like this. On down. So, what you shall, the major point you shall take from here is that in this sparse matrix, there are no concepts in the sense that there's only one in the whole row. And
Please, I have a question.
Yeah, I'm listening.
Please, I have a this line 45.
Okay. This
Line 40. Is this supposed to be Big Mart dot item identifier or item fact?
Oh, thank you. I was actually wondering because I was expecting it to be by 2. Thank you very much. I really appreciate it. It shouldn't be item identifier. Okay. It should be the item facts. As I said, my love for copying and pasting finally failed me. That is the item fact content. That's spelling it correctly. Yeah, so we should reinitialize this, and like we should be getting 8 5 to 3 by 2. Yeah, that's much better now. Uh, okay, so let's actually save this value into a variable. And I should have done that earlier. So I'll just call the variable, but I'm actually tired of keeping names. So I'll just rerun this. I don't know, I don't like repeating a model that I already. Since if we ask for the type of this now, realize that this is a sparse matrix. Something that is only available in this C5. If you want to know more about it, you can actually research on it after this lecture. But one of the ways to quickly access the array within a sparse matrix is by making use of the array array. And that generates this is the array that I'm talking about. So it's a 1 0 0 1. So whenever it sees I believe it setted low path first. So like this. Whenever I see low path, it's describe it as 1. That is low path is present while the regular absent. Low path absent, regular present, and it keeps doing this for the whole picture column. So that is just it for the 3 forms of encoding. That's the label, the the label, the ordinal, and the one hot encoding. And I feel like this particular point that we realize here is something that we could all reflect on. I would really appreciate if you guys could. Maybe I should push this to the GitHub repo. So we'll see if you guys could solve this problem on your own. I expected I should have worked, and I really don't know why. I can't really be debugging in this class. The time is too short for the I kind of appreciate it because I hate debugging in the first place. So the next stuff we're doing now, dealing with now, is the future scaling. And what future scaling is really all about is okay. We want to scale a high range of value. That is, say we had a value, and one of the ways to preview this is making use of the describe keyword, which will preview all the continuous variable data set. So I'll just say the max fields dot describe. So these are the various continuous variables we have in our data set, including the item outlet sales, which is our desired outcome, what we hope to predict. Although we won't be making use of this, the reason being that is our end goal, like what we aim to predict. The outlet establishment, is a year variable. You can tell from the name and max that it's a integer value. That is the 1985 standing for 1985 to 2009. So at least we know the range of years that the outlet establishment has. We have this particular value now, which is the item weight, which range from 4.5 to about 21.4. And the item visibility, which is very, very small, from 0 to 0.32. This is a very, very perfect distance for our data model. What we hope to replicate kind of value for this now, which is the item NPR. And what is the item NPR? So the item NPR stands for the maximum retail price. That's the maximum retail price of the product, whatever that is. But I guess the main point here is that the values, we just want to experiment with the values now. Not that the values are actually that high. The values are pretty small to me, at least, compared to some other values that could be over 8,000 and like this. And you could have, as I said, encoded this, but it wouldn't really matter. And maybe one way you could encode the year values, right, is making use of the minimum. You could perform a standard scaling on this. That is subtracting the minimum from the particular data set and maybe I should just show you what I'm talking about. Let's assume the maximum value is say, I'm almost out of time again. The maximum value is say, let's say the maximum value is 20 and the mean value is 5. What we could do is say, okay, we want to scale this particular value to be in the range of 0 and 1. So we could say subtract both of these values by 5. And the way we can do that is say, okay, the mean value minus 5. The max value minus 5. And I just for speed. Now, if we were to call out both mean value and max value as these two values, we'll have something like it actually have 0 and 15. So that's 0 and 15. That's right. Let's put on the right. That's it. Then we'll divide both sides by the maximum value. We already know that the 0 divided by anything is always going to be equal to 0. So 15 divided by 15 is going to give you 1. That's what I just did now is the min max scalar. I really hope I wrote about it. I talk about it. Okay, yeah, I should. Yeah, I talked about the min max scalar, converting the value, the data sets to the range of value between 0 and 1. So this is the process that the min max scalar actually does. So it kind of like subtracts the minimum value from all of the data. Once it gets the minimum value to be 0, the original intent of doing that is to get the minimum value to be 0. Once it does that, it divides the rest of the data set by the maximum value. So if you say something like that's 0.0 and 1.0. That's just the max scalar for you. The standard scalar is something different, and it's the one that I actually want to practicalize it. And maybe one thing we'll do is I'll still, as I said, I'll still update the notebook on the week. I'm beginning to see a lot of assignments that you guys can do. You could create a function that will replicate this, what I just did in this 4 cells. You will create a function that will replicate that, but it does this for the array. And the way you just do that is you just have to look for the minimum value in the array, the maximum value in the array, then subtract all of the values in the array by the minimum value, which even if it was 0, it should still work. And if it was a negative distance, it will actually work as well. Because say -2 minus -2 will actually give you 0, because the minus become a 1. It is compulsory to do the scaling when you notice your data is skewed. That's an interesting question, a very technical one. So, but if not, let me first start. And how do you determine which of the skills to use? Okay, let me first start by defining what a skew is. One of the ways you can say, I'll ask for what is skewness. SK, how do you spell skew again? SK, what do I do? Skewness, yeah. So if I ask for what is skewness, I actually don't like all of this, but I like the images, right? So skewness has to do with the skewness has to do with the pattern that the data take. And since I believe that most of the people I'm working with are actually beginners, so I'll just try to explain this as simply as I could. But when you talk about skewness in a data set, it just has to do with the patterns it takes when it flows across the rows of the values now. That's the maximum point that a particular value assumes in the graphs, that is something like this. This is what a skewness is really all about. So when a value bends to a particular corner, say here, they call it a positive skew or a left side skew. This is a negative skew, right skew, and this is a symmetrical skew. One that this is the perfect skew. Now, a perfect skew, a normal system. So from the question that I'm saying here, say is it compulsory to do scaling when you notice your data is skewed? Whether you scale your data, skewed data or not, it won't actually affect its skewness, because the purpose of the scaling now is to reduce the effect of the value, to reduce the magnitude of the value. It doesn't affect skewness. And I don't know if I really explain your point. But what I mean by this is that when we made use of the min max scaler on this, right, the value 5 remained the lowest and the value 20 remained the highest, which is 1 and 0. But it didn't like change the overall form of the data, it just converted it. So they say, how do you determine which skill to use? It depends on the problem you're actually trying to solve. That is what determines the kind of skill you make use of. And then the data distribution. Maybe I'll just leave that as a research for you guys. And maybe because I really don't understand the term, the data distribution that you mean, because there are different forms of data distribution that exist. That's the normal, the binomial, the poise, and all
That's
of
not a question, sir. I'm just trying to, when you were talking of skewness, I was just trying to say that it leads to data distribution.
Oh, okay. That's no problem. I'm sure I'm glad you guys get the point. So both the min max scaler and the standard scaler follow the same process. So you just say from that's the same process with the encoders. So say from scikit-learn, that's sklearn, but pre-processing, because they both belong to the same stuff now. Pre-processing, import. It's continued to learn the pre-processing, import min max scaler and the standard scaler. And it's just as we did when we were making use of the encoders. You just have to initialize a scalar. That's it. Scalar. Normally, I usually love adding a prefix, say this scalar or that scalar. Then after creating the scalar, say scalar equals this standard scalar. And that's how you create a simple scalar. Then you fix the value. And yeah, it's not actually compulsory to do scaling for every project. Remember, as I was saying, the reason why I choose this is just for practical sake. The values here are actually perfect. The whole values here, they're actually perfect. As I said, you could actually try to adjust this year value, especially if you notice that okay, there's a lot of data and maybe you just want to do it for doing sake, but this particular value is okay. But for this now, you most likely need, you don't really need rather to adjust this thing. These values are actually small enough. I just want to do this for practical sake, as I said. And we'll have only 1 minute left. So I'll just round up the class with how we scale this. And I think I did the whole code here. What kind of scaling there? Okay, I use this distribution plots to show you. Okay, this is what I was talking about. If you notice, there are no actual change in the value. This is the Big Mart item MPR, which is this. It's not being scaled, and after being scaled, making use of the standard scaler now, that we converted it to a numpy, then do this, what we're all familiar with, then we perform the fit transform. If you realize that the value, the data remains the same, just that the value is changed now between -1 to 2. It kind of like skewed the kind of like compressed the value, which ranged from 50 to 250. From the min and max that we can see here, which is 31 to 266. So just before this thing goes up, I believe you guys learned something today. And that will already be all for this. that will be all for this class. I don't feel like I missed out on anything.